Okay, Algebra 2 students, I appreciate you finding time to get your notes taken care of. These are the last of the factoring notes that we're going to be looking at, and the title of today is Completing the Square. Our objective for today will be the student will learn to factor trinomials by the completing the square method. Now, the purpose of the completing the square method is going to be to find a way around some of the problems that we have been forced to call prime because we could not figure out a way to factor them. Okay, so completing the square is going to help us get past that roadblock so that we can actually get to a factored answer. Okay, so let's take a look. Okay, we've seen some situations where polynomials can be factored. I apologize, I got a grammatical error in there. Okay, we have seen some situations where polynomials cannot be factored. Okay, and some of them do exist. Actually, that sentence has got all kinds of grammar errors. I apologize. Anyway, let's look at the trinomial that's shown there. X squared plus 2x minus 2. Okay, by the way, we've been trained to attack a polynomial like this would be to look at the a term times the c term, and in this case, that would be a negative 2. Then we would take this 2, we would break it down all the different ways that we can and look at the pairs of factors. And of course, the only way a 2 will break down is a 1 and a 2. Now what we would want is we would want this 1 and this 2 to be able to add or subtract to equal the b term, which is 2x. And we can very quickly see that there is no way to add or subtract a 1 and a 2 to get the b term, which was 2. Okay, so at this point in time, we would have been stuck. We would have been forced to call this a prime trinomial and say that it could not be factored. Okay, and basically what that means is we have no rational numbers that will work out to factor this problem, but there are plenty of irrational numbers that can get the job done. Okay, completing the square is going to allow us to get past this roadblock and see how this thing will actually factor. Okay, so what the completing the square method does is it allows us to alter the equation so that the trinomial we are looking at will become a factorable trinomial, in the sense that we can make it a binomial squared. Now that probably sounds very confusing at first glance, but you'll see this very clearly when we get to the method. And here is the method. Okay, to complete the square, now we're kind of getting back to the quadratics. Okay, we're almost all the way back to it. Okay, but we have been working on trinomial expressions. Okay, meaning we have not had any equal signs. Okay, well, you've got to realize that everything can be turned into an equation by simply adding in equals 0 onto the end of it. So that's basically what we're doing. We have a trinomial that cannot be factored. Okay, so we're going to put that trinomial and set it equal to 0. Now, setting something equal to 0, that's how you actually go about solving for x. Okay. Now, what we have discovered thus far is we have a situation where our a times our c cannot be factored in a way that will add or subtract to equal our b term. So what we're going to do is, it's going to kind of seem like cheating, but we are going to invent a new c term that will actually allow this thing to be factored. Okay, and here is the procedure. Okay, so looking at a trinomial, we have decided that our c is no good. So we are going to kind of blame the malfunction on the constant. So we're going to send it to the other side of the equal sign. So whatever c is, whether it's positive or negative, it's positive, we'll subtract it to the other side. If it's negative, we'll add it to the other side. But either way, c is being exiled to the other side of the equation. Now, after we move the c to the other side of the equation, now we need a new constant. And we want one that will actually work and play nicely with our trinomial. Okay, now there's a step-by-step process for how to do this. Okay, to get a new c term, okay, the first step you're going to do is you're going to get your b coefficient. Whatever that number is in front of x, we need it. Okay, we are going to take half of that b term, half of that coefficient, and then we are going to square whatever that result is. Okay, take the b, half it, and square it. This new value is going to get installed on both sides of the equal sign, because as we know, anything we do to one side of the equal sign, we have to do to the other side to keep the equation balanced. So back to the problem that we were looking at, our generic equation, which looked like this, is now going to have a new term popping into both sides, and that term is half of b squared. Okay, so whatever that number is going to be added or subtracted into both sides of the equal sign. Okay, if you need more time, press pause. Now, looking at this very abstract format that we were just copying down, and this is the same one that you had on the previous slide, so you don't need to copy that equation again. Okay, that is very difficult to see in this format, but what we have done is we've created a trinomial on the left that can actually be factored into a binomial that is being squared. Okay, and what this is going to do, okay, that's the format that it's going to look like. Okay, I understand it's confusing, just copy it down for right now. Okay, that a binomial squared on the left, and the first term is the square root of whatever ax squared is. And the second term is the square root of half of b squared. Well, the square and the square root cancel each other out, so you just have half of b. Okay, I understand it's confusing, but we'll get to some problems. It'll straighten it out. Now, something to take note of is the sign of this binomial might be positive. It also might be negative. Okay, and you will get that positive or negative, that addition or subtraction in the middle of the binomial from the original b term in the problem. Okay, so from this abstract problem we're working, it was a plus, so our sign of our binomial in there is also a plus. Okay. Now, as I've said a couple of times through here, okay, a little disclaimer, it's quite difficult to follow this process with all of the variables in this thing floating around. But keep in mind, each of these variables, a and b and c, throughout that entire expression there, or that entire equation, those are all numbers. The only thing that's not a number is the x that is in there. So once we get a bunch of numbers in there, I think this will make much more sense to you. So let's have a look at an example. The example we started off with was x squared plus 2x minus 2, and we set it equal to 0 when we decided it would not factor. Okay, now we said that what we would do is we will complete the square since it will not factor. And we said that we would blame the constant for this malfunction. The reason it would not factor is because the constant was not participating correctly. So we would send our constant to the other side of the equal sign. So in this particular problem, that would be adding 2 to both sides of the equal sign. Clearly, that leaves you the x squared and the 2x on the left and a positive 2 on the right. Okay, but now we need a new c term to take the place of the one that we got rid of. Okay, so by the process, we will take half of our b and square it. So in this particular case, what is our b value? Well, remember, b is the coefficient in front of x. Okay, so our b is a 2. Okay, so we're going to take half of 2 and we're going to square the result. Now, obviously, half of 2 is just 1, and 1 squared is 1. Okay, this is going to become our replacement c term. Okay, so now going back to the problem with this new value, okay, we got x squared and 2x on the left, and plus 1 now shows up. Okay, over on the right, the 2 was already there because we sent our old c term over there, but here comes the plus 1 that we just invented. You can't do something to one side of the problem without doing the same thing to the other. Okay. Now, obviously, on the right side, we've got a little cleanup that we can do over there. 2 plus 1 is 3. Now, the way we have engineered this new trinomial is it can factor into a binomial squared, as we've already seen. Okay, the binomial will be assembled by taking the square root of the x squared. Okay, square root of x squared is going to be x. The trail term will be the square root of our new constant, okay, which is square root of 1. That is 1. And our sign between those two guys will be plus because our original b term was positive to begin with. So we have an x plus 1, it is squared, and it equals 3. Okay. Now the only thing left for us to do is, you know what, this equal sign was not part of the deal to begin with, so we need to move everything back to the other side of the equal sign. Okay, so I'm going to subtract that 3 back over to the left, and there is our factorization. Okay, the original problem, x squared plus 2x minus 2 factors into the quantity x plus 1 squared minus 3. I realize that's probably very unclear to you at this point. Let's look at another, see if that doesn't help. Okay, so factor x squared plus 6x minus 4. We're told to do completing the square, but you don't have to be told to do it. Any trinomial that will not factor, completing the square is something to attempt. Okay, so let's have a look at it. If we decide that it will not factor, then we will move the c term to the other side of the equation. Okay, so how do you move minus 4? By adding 4. So we moved our 4 to the other side. So x squared plus 6x equals 4. Now we need a new c term. So once again, we're going to take our b value, which is a 6 this time, and what do you do with it? Okay, you take half of it. Okay, so half of 6 would be 3. Okay, and what do you do with that? You square it. Okay, so 3 squared is 9. Our new constant for this problem is a 9. Back to the problem with this. I'm going to add the 9 into both sides of the equation. Okay, obviously on the right side there, 4 plus 9 is going to be 13. Okay, and now let's clean up the left side. We have invented what is called a perfect square trinomial, meaning it will factor into a binomial squared. The lead term is the square root of the first term. Square root of x squared is x. The trail term is the square root of the constant. Square root of 9 is 3. And the sign in our binomial should match the sign of our b term, which is also positive. X plus 3, quantity squared, equals 13. Bring the 13 back, and we've got our factorization. X plus 3, quantity squared, minus 13. Now, like all the other problems we've seen with factoring, you can absolutely re-expand this by doing the multiplication, and you should get your original problem back. Okay. Realize that's probably still fairly unclear for some of you, but I'd like you to use the examples that you already have as a guide. And here are a couple of more examples. X squared plus 2x minus 5. Copy it down, use the examples that you have as a template or a guide for how to work this problem. Some of you are making a regular habit out of not attempting your examples and just walking in the door the next day and saying, well, I didn't get it, that's why I didn't do it. Well, you have examples in your notes. Use those examples as an example for how to work these problems. Follow along step by step. Another problem is x squared minus 5x plus 5. Also look at this one and give this one a try. These are the notes that will be checked in class on Monday. Some of you do not have class on Friday, but do not allow that to be a reason why you put everything off until Sunday night. Hopefully you're looking at these notes Thursday night, looking at the assignment Thursday night, and giving some of the assignment a try. Anyway, I appreciate you finding time to take care of your notes. We'll see you in class either Friday or Monday.